Hello, and welcome to today's lesson, Logical Reasoning number 2. Okay, so we're in our second unit of the logical reasoning topics. We're going to look at lesson 3 here, working at a couple triangle conjectures. First thing we're going to look at, and we've already used a little bit, is the triangle sum conjecture. And then we're also going to look at something that can help us out. It's not necessarily needed every time, okay, but it can help make our work a little bit easier. The exterior triangle angles conjecture. So when we look at the triangle sum conjecture, okay, what we know, and we proved this earlier with a protractor, that the three angles in any triangle must add up to 180. So if we're trying to solve for a missing triangle piece or a missing angle in a triangle, we can set up our algebraic equation. X plus 82 plus 27 equals 180. And then we just go right to the calculator, or if you want to do it by hand, you can definitely do that as well. We can add up the 82 plus 27 to get a total of 109. And then we subtract that 109 from 180 to get our angle measure of 71. Okay, we can always double check by plugging the 3 back into the calculator, okay, making sure that it does all add up to 180 degrees. Okay, now our next conjecture that we have is the triangle exterior angle conjecture. Okay, so in a triangle, the measure of an exterior angle is equal to the sum of the measures of the remote interior angles. And we'll show why this works when we kind of look at it overall. So when I look at angles A and B, we know from before that A and B are a linear pair, and linear pairs equal 180 degrees. Okay, now we also know that if we come inside into the triangle, that if A plus B equals 180 and A plus C plus D, the interior angles, add up to 180 degrees. Okay, we have two very similar situations here. Okay, and notice that we're starting with A, and here we're adding one angle. Starting with A, here we're adding two angles to get the same sum. So what do we know about B and then C and D? The remote interior angles, they have to be equal to each other. So once again, can you use this? Yes. Do you always have to use it? No, because we can use the idea of the linear pair to help us solve any problem like this. Okay, it just takes one small extra step for us to be able to do that. Okay, what I'll do here is I'll really kind of show the two ways you can look at this, and you can decide which way works best for you. We have a 150 degree angle here, so we know that the linear pair has to be 30. So now I have one of the angles. Okay, based on the tick marks, we know that these two angles are equal to each other, so I can call them x and x. So I've got two options here. If I'm going to use the exterior angle conjecture, I know that x plus x has to equal 150. If I just want to use the triangle conjecture, I know that 30 plus x equals 180. Okay, you can see algebraically there's not much difference here. As soon as I subtract 30 from both sides, I get 2x equals 150, which is exactly what I get over here, 2x equals 150. So, you know, if you're a person that doesn't like to memorize a lot of things, this is one conjecture that you can let go, and you can use linear pairs and triangles every time, and it will work for you. We divide both sides by 2, and we get x equals 75 degrees. Okay, just looking at a couple more examples. Once again, remember we've got a right angle here down in the corner shown with that box. So we know that that is a 90-degree angle. Okay, so we have our two options again. We know that 160 equals the x plus 90. Okay, using our conjecture, the triangle exterior angle conjecture, to do and solve for this situation. We subtract 90 from both sides, and we get x equals 70. Okay, so now we know the answer. Okay, but I really want to stress too, when we're trying to minimize things overall, keep a few things straight in our head. We've got a linear pair of angles here. They have to add up to 180. So that gives me the 20 on the inside. And then I can always have x plus 90 plus 20 equals 180, working with the three angles inside the triangle. Okay, so you really want to do and use the process that works best for you long term. Okay, because we get the same answer either way. Okay, now using some of the interior angle conjecture, knowing that the three angles inside add up to 180, notice that the tick marks are telling us that A and C are equal to each other. So then we can give them the same name variable-wise. We'll call them both x. So now we know that x plus 85 equals 180. We can subtract 85 from both sides. X plus x, or 2x, equals 95. And then we just divide out to solve. Okay, remember, especially when it comes to assessment time, okay, always use your calculator to help double check your work so you don't make a small mistake overall. Those are always the worst pieces. And you know, the hardest for me as a teacher is just seeing and knowing that it's a small math mistake that cost a student a point on a test or a homework assignment. Okay, just a couple more examples here to finish up, starting to put some bigger pictures together. And when we start to put bigger pictures together, we're going to have to remember some of our other types of angle pairs that we have. You know, linear pair. We know that A and B is a linear pair. We know that A and 153 is a linear pair. So if A plus 153 has to equal 180, then we know that A equals 27. You know, and we can always test it, make sure that we've got that correct overall. Okay, we also have our vertical or our x angles. You know, scissors angles are another way to think about the vertical pair. So we know that the B and 153 are equal to each other. And one of the reasons why they're equal to each other is they're both linear pairs with A. So if they're both linear pairs with A, they have to be equal in value. Now, the last piece we have is trying to find angles C here. Okay, so we can use that exterior angle conjecture. Now that we have B, we know that that 153 is equal to C plus 64. So then we can subtract out to get that value. Okay, so we have 153 minus 64. To finish that one up, we've got 89 for that value. But then always remember that you can use your interior angles. We know that this is a 27 because it's a vertical pair with A. And then we can use the three angles inside the triangle to add up to 180. Okay, now a few more here. Okay, if we're thinking about this situation, linear pair overall. So when we're looking at these three exterior angles, we have to think about what they could add up to. Okay, so now we know that x is a linear pair with A. X plus A equals 180. We know that y is a linear pair with b. So we've got y plus b equals 180. And we know that c is a linear pair with z. So z plus c equals 180. Okay, so if I try to add these pieces together, I get x plus y plus z plus a plus b plus c equals 3 180s. Okay, now there's a reason why I wrote it as 3 180s, because we'll see that here in a second. What do we know about a plus b plus c? The three interior angles, they have to add up to 180. So I can take that off if I take off one of my 180s, and then x plus y plus z equals 2 180s, or equals 360. Okay, very last example, just showing you that sometimes we're going to give you some problems that are going to involve a little bit more algebraic work. So we have all the interior angles of a triangle. So we know that the three interior angles have to add up to equal 180. Let's clean that guy up a little bit here. Okay, so now what we have to remember is we have to start combining like terms on the left-hand side first. We have a 6x, we have a 9x, and we have a 2x. Okay, so we've got 6 plus 9 is 15, 15 plus 2, 17x. Okay, adding up our constants, we've got a negative 1, a positive 8, so that's positive 7, plus 3 is positive 10, equals 180. And then we can subtract 10 from both sides, and then we've got 17x equals 170. Divide by 17, and we get x equals 10. And then once we have that x value, we can use it to find all of our others. So we've got 60 minus 1, or 59 for this upper angle, 90 plus 8 equals 98 for this bottom one. And you always want to make sure that your angles make sense. This bottom angle is bigger than 90. My answer matches, so things are good. I know that this angle is smaller than 90, so when I plug in and solve for that value, okay, I need to make sure that that answer is less than 90. And then if I want, I could test, add these three up, make sure that they equal 180. Okay, that concludes our lesson for today. Thank you and have a good day.